Alright, so moving on from the series and parallel configurations, the next important rule in the circuit analysis course is the voltage division rule. The voltage division rule just links the individual voltages of two resistors in series by their total voltage across them. So for example here, if you want to find the V1, the voltage across R1, just write R1, divide this by the sum of the resistors in series and then multiply this by the total voltage. The same goes for the second voltage V2, R2 divided by R1 plus R2 multiplied by Vt. Important to note is that this would only work if you can see just two resistors in series, and then you can apply this rule by putting the resistor for which you want the voltage off in the numerator and then the sum of the resistance in the denominator like this and multiply this by Vt. Now I'll show you how this formula actually comes. Because these are in series, I can just give this circuit a current of I and I can write a KVL. I'll just start off from this point and I'll move clockwise. I encounter a minus Vt first, so I write that plus I R1, basically Ohm's law, then plus I R2 is equal to 0. This is a KVL, so I can take I as common here and I can write R1 plus R2 and then take Vt on the other side, and then the current comes out to be Vt over R1 plus R2. This is the current through these two resistors in series. So if I want to find V1 now, that is according to Ohm's law, I into R1, which is Vt over R1 plus R2 multiplied by R1, and it comes out to be 1 over R1 plus R2 Vt, which is the same as this formula. The same goes for V2, which is I into R2. The current would be the same as they are in series, 2 over R1 plus R2 times R2, and hence the formula is derived in this way. So this is the voltage division rule. I'll show you an example through a calculation now. So now I have this circuit and there's a voltage source of 12 volt. I need to find Vx. There are a lot of ways to find Vx, but for now we'll use the voltage division rule, VDR. So the first thing to note is that this is not a circuit like I showed in the previous example, because we need two resistors in series. But something I notice is that these two resistors, they are in parallel because they are between the same pair of nodes. So I'll just combine them using this formula of parallel combinations, and the result comes out to be 2 ohms. So now this circuit actually becomes this, and I can write the 12 volt here, the 4 ohms here, and then here is 2 ohms. This voltage is still the same as Vx because Vx was between these two nodes and these two nodes are still the same. So this is still Vx and I need to find Vx. Now the total voltage across both of these resistors is 12 volts. So I'll just apply the voltage division rule to find Vx. So Vx is basically the resistor for which Vx is across is 2 ohms. So 2 divided by the sum of the resistances, 2 plus 4, multiplied by the total voltage, which is 12 volts. So this comes out to be 2 volts. So this is how voltage division rule is applied in circuit analysis.